Okay, what is up, guys? We are about to do kind of a review lesson here for multiplying rational numbers. And in this case, when I talk about rational numbers, we really mean fractions. We're not really going into decimals too much right now. The central question here is, what does it mean to multiply and divide fractions? And if you're following along in the book, this is chapter 4, lesson 4. Okay, so throughout this whole thing, I want you to think about what it means to multiply and divide fractions when you have something like 1/2 times 1/3. What does that even mean? The standards we're having today is to interpret and compute quotients of fractions. And we're going to do some word problems. And we really want you to be able to make sense of problems and model them with mathematics. So in this case, we're going to use an area model. Okay. So we're going to learn how to multiply fraction and mixed number and to multiply mixed numbers. So we're not going to do a whole number times a fraction, like 3 times 1/2, or even easier, 8 times 1/2. That's the same as 1/2 of 8, which is 4. Okay, so let's start off with an area model for multiplication here. Okay, so area model for multiplication, if I'm trying to do 2/3 times 1/4, and I want to do an area model for that, well, first I can draw any box I want and split up horizontally 2/3. So I have like a bar like that, divided up into thirds, right? Kind of look like a Kit Kat bar or something, except there's only 3. So if I shade only 2 out of those 3, and remember, I can pick whatever shape I want, but this rectangle kind of helps out. I only want 2 out of those 3 bars. Okay, so that's 2/3 of that. So this thing, I want 2/3 of 1/4. So if I split it up vertically by 1/4, like that, this is in fourths. So each one of these sections right here, like this, that is considered a fourth. Okay, so if that's considered a fourth, and I just want 1/4, that's just considered a fourth, and I just want 1/4, I'm just going to shade in 1/4 of that. So if I just shade in 1/4 of that, there we go. And then you look at where it overlaps. So as you can see, the darkest part there is overlapped. And then now you can actually count, right? There are 2 boxes out of 12. As you can see, there's 12 total boxes. So 2 boxes out of 12 are shaded. So 2 out of 12. And remember how to reduce a fraction. If I divide the top and bottom by 2, I get 1/6. Okay, so I get 1/6 there, which kind of is cool because 1/6 is also a fraction, right? So I can actually divide this up into 6. This is 1, 2, 3, 4, 5, because 2 boxes is worth 1/6. 6. So I have 6 red boxes, and one of those red boxes is shaded in. Okay, so, and then you're going to kind of see the rule, and you kind of should be able to notice what the rule is to multiply 2 fractions, you just multiply straight across, top and bottom. You do not need a common denominator. You just go 2 times 1 and 3 times 4. Just multiply across, and then you reduce it, and you still get 1/6. Okay, so that's why we do that. So we'll do another area model for multiplication just to make sure everyone's got it. So we got a bigger rectangle here. I kind of knew that I'm going to be splitting this up into fourths and fifths, so I made it a little like bigger. So here I'm going to do the same thing. Split this up into fourths. So there's a fourth there. So this now it's looking like a Kit Kat bar, right? I'm going to shade in 3 of those 4. Okay, so 3 of those 4 are shaded. So what this is saying is I want 3/5 of that 3/4. Like out of just this part, out of just only the shaded part, I want 3/5 of that. So forget about this part. And then how much of the whole is that? That's what I'm trying to find out. So what I'm going to do is the same thing. I'm going to split it up vertically into fifths. All right. And then I only want 3 of those fifths. So if I split this up in 3/5, I get that. That's going to be what's shaded in. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of a total of 20 boxes shaded. 9 out of 20, you can just leave it there because there's no whole number that goes into 9 and 20. So your answer is 9/20. And you can check that answer as well. You have 3/4 times 3/5. You just multiply across. 3 times 3 is 9, 4 times 5 is 20, and then that's it. We'll talk about cross-canceling a little bit, but just looking at the problem, I can't see anywhere to cross-cancel, so I know that after I multiply, I'm not going to have to reduce anything. Okay, so for you guys, why don't you write a multiplication question for these area models, and then answer it. So I'll let you pause it right here, and then we'll continue. Okay, so after you paused it, maybe you continued, I'll just go over this kind of quickly. Here, this is 2/3. You have 1, 2, 3, and 2 of these over here are shaded in. Okay, then you can see 1, 2, 3, 4, 5. 5 of those are split up, so it's going to be something over 5. And then you can see 1, 2, 3 of the columns are shaded in. So it's going to be 2/3 times 3/5. And then if you multiply it out, if I want to multiply it out, I get 6/15, which is actually true. 1, 2, 3, 4, 5, 6 out of a total of 15. If I wanted to finish this off, I can reduce this by 3, right? Because 3 goes into 6 and 15, which gives me 2/5. Okay, so I can show this 2/5, right? I said my answer is 2/5. I can actually show that there are 2/5 shaded. This can be 1/5. So if I say 3 boxes is worth 1/5, that's 2/5, 3/5, and then these 3, that could be 4/5, and this could be 5/5. So out of these fifths, 2 of them are shaded. Okay, and then for the second one, that's going to be 3/4 times 5/6. And if you multiplied that out, it would be 15 over 24. And then you can see that you can divide this by 3. If you reduce it by 3, you get 5/8. So moving on, I won't kind of go more into that. Okay, we're going to talk a little bit about cross-canceling. Let's say we have a fraction like 5/6 times 9/10. So this isn't too bad. If you wanted to multiply across, you would get 45 over 60, but that's not simplified, right? So I need that to be simplified. So there's a fast way to do it, but maybe you don't recognize right away that they're both divisible by 15. Maybe you just see a 5. So you do this, divide both top and bottom by 5, right? Then you will get 9 over 12. All right, so you get 9 over 12. And then if you're rushing, maybe you're gonna circle or box 9 over 12. But actually 3 goes into 9 and 12. So then the answer really should be 3 over 4. That's what your answer should be. If you put 9 over 12, that's like partial credit because you multiplied it, but it needs to be written in simplified. So a faster way to do this, which works every time, is if you do something called cross-canceling. So do this here. If you have 5/6 times 9/10, you can do something cross-canceling. So you can look up and down or diagonally. Mostly it's diagonally because you're assuming that these fractions here are already simplified, because that's the first thing that you should do. Make sure both of the fractions are simplified before you start. So assuming they're both simplified, you look diagonally. So 5 and 10. What goes into 5 and 10? 5. So I can cross-cancel there. It's like I'm dividing by 5. I'm dividing by 5. right? So 5 divided by 5 is just 1. 10 divided by 5 is just 2. And I can do the same thing with 6 and 9. Here and here, they're divisible by 3. So I divide by 3. I can divide this by 3. This is 2, and this is 3. So this is where it helps to be very neat with your work, because you have to know what you're multiplying. So and right now, I'm left with 1 over here times 3, and a 2 times 2. Right, so now 1 times 3 is going to be 3, and 2 times 2 is going to be 4. So that looked a little more tedious, but that's because I'm explaining it as I'm going through. When you see problems like this, you'll be able to do this a lot quicker, and it'll save more time than what you did above, especially with harder fractions. Like these are kind of simple fractions; they're not too bad. But with more complex fractions, it's going to save a lot of time and avoid you not simplifying completely. Okay, now we've done a fraction times a fraction. Now we can do a fraction times a mixed number. So what you definitely can't do is you can't just go, okay, let's see, there's nothing here, it's 1. I guess this is just 1. 1 times 3 is 3. 3 times 4 is 12. 1 and 3 twelves is 1 and 1/4. Definitely not what you're supposed to do, because basically you just ignored the 1. So we're going to totally erase that. You cannot multiply mixed numbers unless you convert them into an improper fraction or a common fraction. I like calling them common fractions because it's not like it's improper to have it that way. These 1 and 3/4 is preferred by some people, but the improper fraction, or if I switch this, here, if you remember this, to change this into a common fraction is 4 times 1 is 4, and then plus 3 is 7. So I can change this. This is the same thing as 7 over 4. And improper fractions or common fractions are actually preferred in a lot of places when you get to algebra. So it's not really improper. So now I have this. I'll just rewrite this down here. 1/3 doesn't need to change, and times 7/4. So right now I'm looking, okay, 1 and 4, there's nothing that goes into 1 and 4. 3 and 7, nothing goes into 3 and 7, so I know I cannot do any cross-canceling. So then I'm going to go ahead and multiply across. 1 times 7 is 7, 3 times 4 is 12, and the fact that I checked if I could cross-cancel first, that means I can confidently box 7/12 and know that it's already simplified. Okay, let's look at another example. Yeah, let's look at this example here from the book. It says Mr. Conrad's pecan pie recipe calls for 1 3/4 cups of pecans. He plans to make 8 pies for his family reunion. How many cups of pecans will Mr. Conrad need? So that means each pie, for 1 pie, he needs 1 3/4 cups. So if he needs 8, you're going to have to multiply. So I'm just going to write this as 8 times 1 3/4. So I'm going to have to change both of these into common fractions, because 8 by itself, some people might get confused by that. So this 8 really is 8 over 1. Okay, because any whole number or integer as a fraction is written as that number over 1. And I'm going to change 1 3/4 to an improper fraction. And we already had this before. 4 times 1 is 4, plus 3 is 7, so this is going to be 7/4. And to save time, I will cross cancel. I can see that 8 and 4 goes into both of those numbers. So 4 divided by 4 is 1, 8 divided by 4 is 2, and then now I can go ahead and multiply across. 2 times 7 is 14 over 1. So when you're writing an answer, you want to simplify it. 14 over 1 should just be 14, and since this is a word problem, it says how many cups of pecans will Mr. Conrad need. I will just write, and then don't forget about the unit, cups of pecans. All right, and there's that. Okay, so why don't you guys go ahead and try this one. Find 5.5 times 1/3, pause it, and then we'll continue. All right, assuming that you did it, hopefully. You're going to have to change 5.5 to an improper fraction or a common fraction, right? So 2 times 5 is 10, plus 1 is 11 over 2, and then 1/3 stays the same. I cannot cross cancel anything between 11 and 3, 2 and 1, so I'm just going to multiply across 11 over 6. Now, it says write in simplest form. Someone say, oh, I need to simplify. This is actually simplified. 11 over 6 is an acceptable answer unless it tells you somewhere that it needs to be a mixed number, or if it's a word problem and it asks how many pecans or something you need to buy, how many cups of pecans, then it would make sense to make it a mixed number. But technically, this is actually simplified. If I want to make it into a mixed number, you can. 11 divided by 6, right, is 1. And then this is where remainders are still used in 6th grade. Remainder 5. So I will have 1, and the denominator is always going to be the same, but my remainder is 5/6. So 1 and 5/6 or 11/6 are both acceptable answers. All right, let's try another one then. Okay, let's try another one here. Now I'm changing it up a bit, but not really that much. I just have 2 mixed numbers multiplied by each other. So not a problem. We're just going to have to change both of these into common fractions. So going this way, times, plus, right? So 8 times 1 is 8, plus 7 is 15, and the denominator always stays the same. Times 3 times 3 is 9, plus 1 is 10, and the denominator stays the same. And then hold on, because we want to make sure that nothing can be cross-canceled. Well, in fact, we can a lot here. Let's look at this first. 15 and 3, right? 15 and 3, I can divide by 3. So this actually can become 1. 15 divided by 3 is 5. Now I can look at 8 and 10. 2 goes into 8 and 10. So I can cross-cancel 8 and 10. 8 divided by 2 is 4. 10 divided by 2 is 5. Now I can go ahead and multiply those that's left over. So in this case, I have 5 times 5 is 25 over 4 times 1 is just 4. And again, since I cross-canceled completely, I know that this is simplified. So there's a difference between simplified and mixed number. This is simplified. If you wanted to make it a mixed number, you divide. If you can't do it in your head, go ahead and just on the side, you could just do 25 divided by 4. That's 6. 6 times 4 is 24, and you have a remainder 1. So this is going to be the whole number, 6, and then the fraction is going to be the remainder, which is 1, over, and then the denominator doesn't change, so 6 and 1/4. But both of these are acceptable answers. Why don't you guys go ahead and try this one. Find 3 3/4 times 2 4/5. Pause it. Okay, so last example here, this is another mixed number times a mixed number. So I'm going to have to change this into a improper or common fraction. So 3 3/4, 2 4/5. Okay, 3 3/4 times 2 4/5. I'll try to do this a little faster. You're going to change these into common fractions. So 4 times 3 is 12, plus 3 is 15, over 4, times, and 5 times 2 is 10, plus 4 is 14, over 5. I can reduce. Divide by 5, this is 1 and 3. Divide by 2, this is 2 and 7. Then I can multiply across what I have left over. 3 times 7 is 21, over 2. Again, an acceptable answer. Or you can change this to 10 and 1/2. And there you have it. Okay, so hopefully that was a good review for multiplying fractions. Next time we're going to be doing dividing and then moving on to adding and subtracting, just to review these concepts. Okay, so have a good day, and I'll see you next time.